We can also put our linear inequalities in slope-intercept form, right? And it's still going to be the same. They still have a slope. This is still the y-intercept, even though now we're working with inequalities. So let's practice doing that, remembering that if we divide or multiply by a negative, we need to flip the sign. So here I have 5x plus 3, there's supposed to be a y there, is greater than negative 6. So I'm going to go ahead and subtract 5x from both sides. That gives me 3y is greater than negative 5y x. Oh my gosh, you guys. 5x minus 6. And I'm going to go ahead and divide both sides by 3. So I get y is greater than negative 5/3 x. Negative 6 divided by 3 is a negative 2. Okay, so now I have taken my linear inequality in standard form and put it in slope-intercept form. So my slope is negative 5/3. It's got a negative slope. It looks like it's going downhill. And my y-intercept is negative 2. I'm going to go ahead and change colors. So why don't I go ahead and solve this second example? Again, we're trying to isolate y, get it all by itself. So I'm going to add 2x to both sides. That means negative y is less than or equal to 2x plus 4. And now in order to get y all by itself, I need to divide by negative 1 or multiply by negative 1. That means y is greater than or equal to, see, because I divided by a negative, I flipped the sign, negative 2x minus 4. Now, when I'm graphing these, if I have x is greater than or equal to a, the graph consists of all points to the right of and on the vertical line, x equals a. If I have x is less than or equal to a, remember these are x equals a is a vertical line. Its slope is undefined. So x is less than or equal to a consists of all points to the left of and on the vertical line, x equals a. We will display the graph by crossing out the proportion of the plane that's not part of a solution. And this is a warning. So we should use some orange. Warning! For those of you who took my college algebra course, this is the opposite of what I taught you. So be sure when you're reading in the book, you realize that this is the way the book does it. I think it's silly. But so that's the way we're going to do it in this section. So please try and keep that in mind. And math can be really funny sometimes. That's what I said. You can quote me on that. All right, let's graph the solution of 4x is greater than or equal to negative 12. So we're going to go ahead and find our solution. First thing we do, divide both sides by 4. So I have x is greater than or equal to negative 3. So I would go to where x is negative 3, graph that line. And then my solution is everything where x is greater than negative 3. So like x is greater than negative 2, this is a solution, this point over here. So this side is our solution. And we're crossing out our not solution. So why don't we go ahead and graph 3x is greater than or equal to 12. I'm going to divide both sides by 3. I get x is greater than or equal to 4. So here I have x is 1, 2, 3, 4. Graph my line. And then my solution is when x is greater than 4. Well, x is greater than 4 over here, right? At 5 and 6 and so on. But I am shading the part that's not part of the solution. So I'm going to shade over here. I could have done this a lot more neatly. How's that? Beautiful. Okay, so then this is our solution to the right over here. Next, why don't I graph the solution to y is less than or equal to negative 2? I feel like you can figure this one out. So where's y negative 2? Right here. So I graph my line, y equals negative 2. And then I have that y is less than or equal to negative 2. So that would be down here, right, where we have negative 3 and negative 4. So this part's our solution. So we're going to shade the part that's not our solution. Beautiful. So when I'm graphing linear inequalities, I draw the line y equals mx plus b, and then I cross out the portion of the plane that's not in our solution, so the part that does not satisfy our inequality. When y is greater than or equal to mx plus b, our solution is all points above the line, and when it's y is less than mx plus b, our solution consists of all points below the line. So here I have the line, the inequality 4x minus 2y is greater than or equal to 12. So what I need to go ahead and do is solve for y, which we are experts at by now, if I may say so myself. Greater than negative 4x plus 12. And I need to divide by negative 2. That means I got to flip my sign. So I have y is less than 2x minus 6. So I go ahead and graph my line. Awesome. But now I have y is less than. So my solution is all this white space over here. So I have to cross out the part that's not part of my solution. If I do this, I can make it plaid. And here it is going to show you step by step. I put that in the PowerPoint, so if you are having difficulty downloading the videos or you're working through the PowerPoint, you can check your answers. Remember, these videos are a good learning tool when paired with the PowerPoint itself. So why don't we graph the solution to 3x plus 2y is greater than or equal to 6. First things first, we got to isolate our y. So now I have my slope, I have my y-intercept. It's important to remember that this slope is negative, so my graph's going to look like it's going downhill. So I graph my y-intercept. My y-intercept is 3, so 1, 2, 3. My slope is negative 3, 2. And remember, slope is rise over run. So I'm going to go down 3, it's like an anti-rise, and over 2. Oh, I found my x-intercept. That's exciting. And I can do that a couple more times just to practice graphing because it never hurt anybody. And then I have to go ahead and graph my line. But I'm not done because this is a linear inequality. And I say that y is greater than. Well, greater than means that my solution is up here. It's above the line. This is our solution, this half plane over here. So what I'm going to do is I'm going to cross out the part that's not in our solution. That was better. It was more tame scribbling.